Okay, hello everybody. Today is September 22nd and 2021. This is the Kubernetes SIG architecture um, production readiness sub-project meeting. And thank you all for coming. Um, so I think we have two things on the agenda because um, uh, I want to find out from David. Um, but let's get started with the discussion of CPU manager policy feature gates. Swati?
Hi. So this was a new feature that was introduced in 1.22 CPU manager policy options that modifies the behavior of CPU manager, and we introduced an option called pCPU only in the release in 1.22 release. This release we are graduating this feature to beta, and we are trying to evaluate what's the best way of handling experimental options that get introduced. So in addition to this feature, there is a new policy option being introduced in 1.23 release, which kind of distributes CPUs across NUMA nodes. So I think John and I had a discussion on the best way to handle it. One was obviously to have feature gates corresponding to each policy option that gets introduced, but then that is a bit cumbersome. So we came to the conclusion that we can have a feature gate that is basically for experimental options, and as the feature options, as the options become more mature, they graduate from being under a feature gate to being kind of enabled by default. So I think during the review process, Derek flagged that this is a bit kind of abnormal and this is not something that is usually done, but we wanted to bring this to everyone's attention and see if there are better ideas on how we can kind of go about this.
When you say not enabled by default or enabled by default later on, you mean accessible by default and someone would have to basically type the flag and name in. But at that point, it would be beta and not alpha, is the idea.
Yeah.
Okay.
Yeah, so there's the underlying feature of you can supply options, right? And that I believe just went beta, if I recall,
so we are trying to, yeah.
So I see, just looking at this, sorry to jump in, I see like at least one issue here, which is we can't rename feature gates. So like,
no,
because
we're not renaming it. We are introducing another one.
Yeah, the cap suggests that it's being renamed. So now we need to deal with whatever we need to like deprecate the old feature gate because I think that one existed already, right? It was already in alpha.
Let me clarify. So the question here is we have a feature gate that controls whether you can use the policies at all. And the question is that if you've got, forget this specific example, this is really a general question, right? If you've got 10 different policies today, right? When the overall feature goes to beta, that feature gate's going to enable and effectively make beta every one of those options. Now, next release, we come out with a brand new option, but it's not beta quality. How do we control access to that option? And the statement was, let's create, we have two, I don't want to use that word. We have two ways we can do this, at least two ways we can do this. One is we can say for every new CPU manager policy option that we create, we're going to add a feature gate. And so in order to enable that option on some particular kubelet, you have to pass in that feature gate, and otherwise that option will get kicked back as invalid. That's one way, and that would work with our existing process. But that means that we're proliferating a lot of feature gates. Basically, we're saying you have to set these two flags instead of one. And that's our whole deal. What I was suggesting, which may be a bad idea, is that we essentially create a feature gate to control access to new experimental or alpha options for this flag. So now, without the feature gate enabled, your options are limited to that initial 10, say. If you enable the feature gate, you get access to an additional 5 options. As those options mature, they come out from under that feature gate. Now, because we have one feature gate, in this case, for those options, there's no alpha beta stable. There's basically, other than documentation. There's alpha hidden by a feature gate, and then there's the core feature, which is no longer hidden by a feature gate once it goes stable. So those options fall into that. So we theoretically could add, another feature gate. But the question at hand, I think, for this group is what's too burdensome, what's too cumbersome, what's not safe enough. And so I hope that clarifies kind of the.
Yeah, so the reason that I sort of jumped in is I don't know that this is a PRR question. Like, to me, this seems like a wider SIG architecture question, because we're talking about like how we want to manage feature gates, which isn't limited to PRR. I think in this particular place, like I see the goal of PRR is, can the thing be turned off? Can we make it stop like breaking things, basically? I think if you don't specify an experimental feature gate, then it's not on. And like, as long as there's a risk, of course, if the implementation goes in and touches a bunch of stuff it shouldn't, maybe adding that alpha feature gate broke some things, and then it affects other things. But depending on like how it's implemented, it might be really hard to stick all of that behind a feature gate anyways. And this is a risk of any change in Cube. So I would see the scope of PRR as being limited to, can you turn it on or off, and what are sufficient mechanisms for that? Because there's lots of things in Kubernetes that can't be feature gated, like metric stability doesn't follow feature gates. There's like a number of things with like log transition or like that kind of thing that like don't follow like an alpha beta sort of process. Creating new APIs does not go through alpha beta graduated, right? It follows the API versioning process. So,
but new fields in those APIs do
yes,
use the feature gates, and we don't consider it too onerous to enumerate a feature gate per new API field.
Yes, but in this case, I think we have one API field that we can add new string values to. So, like, I previously, like, I think I agree. It makes sense to have like a feature gate per API field, but in this case, it's like a feature gate per option in that API field, which is not precedented as far as I'm aware. But in any case, like, that's a question for API review. That's not a PRR thing.
Well, so for me, these are kubelet flags; they're not APIs, so it wouldn't really fall into API review.
Well, the kubelet configuration is an API, so it would fall under API review.
So for me, conceptually, it is actually a field in the API. We can treat that option as an enum, right? And then like we are adding a new enum option field, however we call it, whatever the best name is here. The value. The value, yeah, exactly. And so that is actually part of the API to me. So it's in a way like, it's not a field per se, but it's a thing in the API. So
yeah, the other thing I should clarify, it's not merely like a flag or something like that. Like generally, I guess, I don't know what's happening with working group component base, but they're disappearing. But generally, we're trying not to add new flags to components. Everything that exists as a command line flag also needs to exist in the configuration API. So like every time you change something, like you add a new option to the kubelet, that is an API change. Now, it's not like one that needs to be serializable by clients, but it's still considered an API change. It's still like, as far as the changes you need to make in the code base, it's almost identical to a regular old API change. It's just which is a different spot.
Yeah, okay, exactly. Which is roughly what I was trying to say. So I think that I would actually personally prefer to have like a feature gate per value. But my question here is like, why did you? So what was the reasoning behind like having this like feature gate pay per group of fields or per current state of those? Is it because like adding feature gate is too expensive? It doesn't seem to be, right? It's pretty easy to add.
So well, go ahead.
Yeah, I was going to mention that we have a feature option being proposed this release. We have at least 2 more that we see coming in the near future. And then there are possible modifications of CPU manager that might happen in the future based on like some components like CMK and the other components that exist. So I think that there are going to be a lot of CPU options, and that's the reason we thought that it's probably best to have some sort of an experimental feature gate, a feature gate for all those kind of experimental options, because then it means that if, for example, down the line we have 6 feature options, we'd have 6 feature gates associated with that. And then for each of those, we'd need graduation process kind of updates to the KEP, which, and of course, removing the feature gate if the option becomes beta. And that seems like a lot of process for something that is relatively.
Don't you already have to have graduation criteria for each of the individual options? How would you know when they're ready to graduate without having that criteria?
So David, just to like, from another example in Node, looking at, for example, swap, like we have one feature gate that controls the API field in the kubelet configuration and the initial graduation criteria for like alpha, where we have these 2 options. Part of the beta criteria is maybe add another option. But then, like, you know, by that point, you know, it's going to be turned on by default. Like that new option is not necessarily going through another like deep, like, you know, full feature flag cycle. I think the fundamental question on the table is, for a given API field, do we have separate feature flags for each possible new value? And that to me is an API review question, not a PRR question. And I don't know of anything that we've done that for previously in the project, but PRR is relatively new. So
I don't know. I'm pretty interested in how you would decide whether an option was ready to graduate from beta to GA without having criteria for that option.
Like it needs to be tested, right? It needs to go through the same process as everything else. And perhaps like this is the complex thing. In some cases, like, so for something like swap, right? Like that feature kind of has a life cycle that will graduate as a thing. And then maybe future down the road, we would say, okay, we want to add another field to that. There's a question of whether or not, so like certainly there's like a feature, but then there's a question of like, okay, but is it an enhancement? So like if a feature is like, whatchamacallit, confined to a single SIG, right? That doesn't necessarily need to go through the enhancement process. It's only if it touches multiple places or APIs or that kind of thing where it might cause breaking changes that normally we would go through the enhancement process. So like there's plenty of examples of things that we wouldn't go through enhancements.
A CPU manager policy you're going to need, that's going to, like, if it's going to need, like David's saying, graduation criteria, it's going to need some of that process. So I was thinking more from the user point of view in managing and tracking, like, okay, I already don't get this feature unless I actually, choose the option in my flag. So it's not like you can't turn it off in the sense of the user here is not just any old user coming in, right? This is the admin who's setting kubelet flags. So how much protection do they need when you're talking about setting, you're already not going to be using the option. If the option's broken, you can already turn it off. So by just not using it. And as the cluster operator, I'm the only one touching my kubelet parameter. I don't know about you guys, but I don't let users do that. So to me, it's sort of like, okay, so now I have to go look up the other value. I have to set 2 flags in order to use 1 flag. And, I can see some value in saying, I'm not going to let me just use any old option, like David's first comment here. How can you predict the stability level? The feature gate tells me, okay, it's at a low stability level, and so now I'm going to have options of low stability options. But having separate ones for separate options doesn't gain me anything and has a cognitive overload of having to keep track of all of those. Because it doesn't gain me visibility about the stability level, and it doesn't gain me control because I'm already the one. Anybody who can set the option can also set the feature flag. So I just don't see the point in it other than causing. There's two ways to cause confusion. One is by not doing things the way everybody else does them. That's the confusion I'm picking over the confusion of the proliferation of feature gates. I don't know what's the better choice, but this is my thinking.
As an admin, I would say having a feature gate for every option would be a giant pain in the butt. I would also say, like, again, PRR's job is to determine, is the thing working properly and can I turn it off? Don't specify it. Thing is now turned off. Like, this is not a thing that we can really turn off or on at runtime because it's part of the kubelet config. It's not intended for that. Like, restart the kubelet, don't pass that config if you think that it's broken. Because it's limited to the node and it doesn't have like the ability to like take out the whole cluster or something. To me, that's acceptable from a PRR point of view.
You only have to specify 2 feature gates, or a feature gate and a flag, if you wish to use something while it's still in alpha. You don't have to specify both once it goes to beta. I find the solution to be fairly clever. I really am unclear on how you would choose to graduate a new option from beta to GA without having criteria. I don't understand that.
I mean, it's also
and I'm
like
sorry,
a metric.
I don't think that's a question. I think
but it's also better.
There would be criteria. There would be criteria. I'm not sure, David. Like, nobody suggests. I don't think anybody's suggesting there'd be no criteria. All we're talking about here is this mechanism for how we control access to that, and to your point, how we make it explicit when someone wants to use this option, they explicitly have to sort of state, I know this option might be shit. Sorry for my language, but I'm going to put this feature flag on here. I know it might not work because you're telling me without this feature gate, I can't turn it on. But that's accomplished by essentially a single feature gate for the entire suite of experimental options. We don't need a feature gate for every single experimental option to get that positive acknowledgement and make sure the person knows what they're doing.
So I think
different what you're saying, the graduation criteria.
Yeah, so I think that at least how I partially interpreted David's comments is that given that we need that process anyway for graduation criteria and stuff like that, being forced to graduate the feature gate itself doesn't seem to be a significant overhead for that. So I think that I basically referring to Swati's comments is that like we have this, we need to have this process anyway, and we will have it because we need graduation criteria and all that stuff. So it should probably be going over a cap or something like that, maybe a common cap, but still something. So having this additional feature gate doesn't add much work, in my opinion. I think there is a question like that Elana said, that from the operator's perspective, operating on or having a bunch of feature gates is potentially painful. I think the counter example here is like, let's say that we have a bunch of those in beta already, but as an admin, I actually want to disable some of them because I want to wait for X, Y, and Z until they GA because I just don't trust them. I want to enable this single option.
I have a quick question for Swati.
Except Wojciech, we're talking about kubelet. We're talking about kubelet config. So we're not talking about we're not talking about 2 different people. We're not talking about the administrator making these options available to the users. I guess you could, in a larger environment, imagine that there's some sort of policy that people are putting in place on some sort of build pipeline that's going to control those options, but you wouldn't use a feature gate for that anyway. Like, it's what you're saying makes perfect sense if this were an ordinary API that was user accessible. As a cluster administrator only thing, it's the same person making that choice. So there's
okay, I got it. Yes, that makes sense.
I have an answer for like for in order to disable a particular option, even if the feature gate is enabled, if you don't specify the option in the list, you don't use the option. So it's fairly simple.
Yes.
But essentially having the feature gate enabled gives you the accessibility to that option. Whereas if you were to use that particular option without feature gate enabled, you wouldn't be able to access it at all.
So you've answered my question. I think there's a list, right? So I guess one thing that I am a little bit concerned about, given just sort of the discussion, is we're talking about like, okay, you might have 10 experimental options in the future. How are we testing the matrix of all of those being on or off? Like that to me potentially brings in problems because, okay, we've got like 10 options. And if I specify 9, secretly there's a broken code path if I don't have the 10th one. Like, how are we dealing with that test spread in turn? Like that becomes a little bit more of an implementation details thing, but I am a little bit concerned if like the goal long term is like, okay, well, we could have like 15 or 20 of these options, and that's why we don't want to have a feature flag for each one. Well, then how are we dealing with the combinatorial overhead of complexity in testing of like, okay, well, we have 15 features and we have to test every single possible combination of each one being on off. Initially, I thought, well, it's, there's like 10 different features, but you can only use one at a time, in which case, whatever. But if it's like, you could have anything, then I think that starts to go down a path of like, is that what we want?
That is a good point. I'm not entirely sure if, like, I think at this point in time, you could specify multiple of those, but maybe a way for us to handle is that we kind of restrict a few, which maybe some of the options, it doesn't make sense to use them together. And we need to kind of handle that with the implementation documentation, because like you said, the test overhead is going to be massive because some options are probably not going to make sense with the others. And
just like a validation and like okay, we say that you can and cannot turn these things off, but if the issue is, okay, we have like 15 things, then from a like PRR perspective, a thing that we do need to check is, can we turn each and every one off independently of each other? And then we have a really big test matrix. So I don't know that came up in PRR review previously, but that is like, I initially thought, okay, well, we've got all these options, but you can only use one at a time, in which case, okay, sure, it's kind of moot. I didn't realize it was a list. If it's a list, then I think that's something that we missed, and that's something that we need to consider. And I don't know if having a feature gate for each option there makes that better or worse.
But don't you think, like, as the options get introduced, this is a question that we handle at that point, because like it depends on the option itself. Like, does it make sense to use that option exclusive of the already existing options, or does it make sense to use them in addition to the ones that exist? So it boils down to, like, as we go on and more options get introduced, and we tackle that at that time.
Oh yeah, I think that makes sense. I don't know what the exhaustive list of options is right now, though.
Yeah, at this point in time, I think we just have 2. We have a full CPU only, and there's another one that Kevin is introducing. So those are the 2 that we're going to have. So what we're proposing that in 123, we have the feature as well as the full PCP only option enabled by default, and thus graduating it to beta. And the other one is going to be behind the experimental options, and that's essentially what we're discussing at the moment.
Are you planning on having, it sounds like this particular feature gate will never graduate from alpha to beta. Its point is to be alpha. Are you planning on having a separate one for beta as well? To be clear, I'm not strictly against this. I do think it might make sense to bring up in a more general SIG Arch call. But I think of myself as like a cluster admin. I can actually today write something that turns off all beta features, and I can do that globally for all my processes, right? Because I can say, I can look up all the feature gates, I can see what status they are, and and then disable all beta ones. Am I going to have that ability?
So that was an open question as something we could potentially do as we need to do that. So right now, that wasn't the need. It would have been an empty feature gate that did nothing. In theory, we could add one for that purpose, but if this is the wrong approach entirely, obviously we won't. So, okay, I guess you have to go, David, and it sounds like the consensus is that this is not the right group to talk about this. Swati, would you mind sending an email to SIG Arch, kind of laying out the question here, which is, what do we think as a group is the right way to do this? And I can chime in on that then and give my thoughts on it as well. And then we can talk about it in SIG Arch or an API review meeting or somewhere. That would be the other question is, do we need everybody in SIG Arch? Do we want to do it in an API review meeting? I don't.
API review doesn't have separate meetings, so SIG Arch is probably the right forum for it.
Yeah.
Okay.
And I do think that similar discussion would have happened, so I don't feel like this was a waste, because it lets you write that email and say people who are interested have said these things. So.
Yeah, no, this is a great discussion. Thanks for bringing it to us.
Yeah, I'll draft an email and then send it to SIG Architecture, and then we can make the discussion from there.
Thank you.
Thank you so much for your time.
Yeah, thank you. Okay, so David, you said you have to drop. So
yeah, but I will give you the 1 minute update. So I have gotten, you got the BigQuery data set created. I've gotten the data imported into our data set. I've gotten it manipulated so it's in the reportable format. I'm trying now to wire up a report to prove that I can make a report work. And then I have to go refine the old queries to make the reporting structure match. But the data is present and it's already been massaged into that right shape. And now we just have to make all the secondary lookups.
Awesome. Okay, so if there's anything you need from me as far as finding my old queries and getting them to you, I tried to share, I think, most of them with you, but
okay.
Who knows? So let me know.
Thanks. All right, I got to drop and talk to
All right. Well, thanks, David. We'll see you later. I think that's actually everything on our agenda. Does anybody else have anything they wanted to bring up, or we can get half an hour of our lives back?
Do we not,
okay,
not
awesome.
today maybe, but do we want to do a post-mortem of PRR from this release at some point?
Sure. Yeah, that makes sense.
Maybe next meeting.
Maybe next meeting. Yeah. Awesome. Great. Thank you, everybody.
Thank you.